Section 5.6 is on indeterminate forms in L'Hopital's rule. So we're going to look at and remind ourselves what indeterminate forms were, and then we're going to learn L'Hopital's rule and learn why it's such a beautiful rule and how it can help us determine indeterminate limits. So we are actually taking a step back to our first chapter now, which was on limits, and we used to evaluate some of the limits and then had some issues trying to do it. So for instance, the first and most main indeterminate form we saw was of the form 0 over 0. So imagine if you were trying to evaluate the limit as x approaches -1 of 2x squared minus 2 all over x plus 1. If I plugged in the -1 on top, this would be 2 minus 2, which is 0, and this would be -1 plus 1, which is 0. So we get that indeterminate form 0 over 0. The trick of this was trying to factor, and if we tried to factor this, we would end up with, well, it has a common 2, so that'd be 2 times x squared minus 1 all over x plus 1. But that factors even further into 2 times x plus 1 times x minus 1 all over x plus 1. And then if you remember, you could simplify the factors, and this would be equal to what they have right here, the 2 times x minus 1. So they skipped a couple of steps there, but that was the idea. And then the idea was once you have factored and simplified, you can actually evaluate. That'd be 2 times -1 minus 1, plugging in for x, right? Plugging in the -1 for x. And that's how they got the answer of -4. So there were ways of evaluating some indeterminate limits, limits of indeterminate form when you got 0 over 0. We also looked at infinite limits, and when we looked at infinite limits, this was the thing that we looked at. What happens as the limit as x approaches infinity? If you remember, this was a horizontal function, horizontal asymptotes. We're talking about the in behavior here. This one we would have said that it's balanced, and because it's balanced, all we care about is the ratio of the leading terms. And so this would have ended up being 3/2 is what the answer would have been. So we would have said this one is balanced. We also had top heavy, where we know it goes to infinity or negative infinity. And we also had bottom heavy, where it went towards 0, right? But this was a case when it was infinity over infinity. And so we were able to solve some of these indeterminate forms. 2 of the indeterminate forms being 0 over 0, and one of them being infinity over infinity. It says, occasionally you can extend these algebraic techniques to find limits of transcendental functions. For instance, the limit as x approaches 0 of e to the 2x minus 1 all over e to the x minus 1. Notice if I put in a 0, this would be e to the 0, which is just 1 minus 1. So I'd have a 0 on top. E to the 0 again is 1, so this is 1 minus 1, 0 bottom. So this would be 0 over 0. That's our indeterminate form, right? So we know it's our indeterminate form. And if it's our indeterminate form, we have more work to do. So what they did on this one was they realized, look, technically this is e to the x quantity squared minus 1. So it is a difference of squares. So they factored it into e to the x plus 1, e to the x minus 1. On bottom, they have e to the x minus 1. So you know those two factors simplify. Once those two factors simplify, you're left with just e to the x plus 1. Then you could plug in the 0, so you could actually evaluate it. So this would be e to the 0 plus 1, which is just 1 plus 1, which gives us the 2 that they got right there. So again, skipping several steps, but that's how they got their answer right there of a value of 2. So they're saying sometimes you can algebraically manipulate it to be able to get that, okay? But then it says not all indeterminate forms, however, can be evaluated by algebraic manipulation. This is often true when both algebraic and transcendental functions are involved. For instance, the limit. Consider the limit as x approaches 0 of e to the 2x minus 1 all over x. So notice that'd be e to the 2 times 0, which is e to the 0, which is 1. 1 minus 1 is 0. So on top we would have 0. On bottom we would have 0. This is 0 over 0, which is the indeterminate form. And then what they said is you could separate this. So you could look at this as e to the 2x over x minus 1 over x. And you're looking as the limit as x approaches 0. And if you look at the limit as x approaches 0, this actually approaches positive infinity, and this approaches infinity. So what you have would be infinity minus infinity, which is what they're talking about right here. They're saying that's another indeterminate form, and infinity minus infinity is not 0, believe it or not. It says, of course, what you could do is use technology. So all they did was use the table feature on the calculator again. They put e to the 2x minus 1 all over x in there. They looked at the limit as it approaches it from the left. It's getting closer and closer to the number 2. From the right, it's getting closer and closer to the number 2. So our guess would be the limit as x approaches 0 of e to the 2x minus 1 all over x would be equal to 2. So that would be using technology. So the question then becomes, can we use some form of calculus to make this easier? And the answer is yes, and that comes in the form of L'Hopital's rule, which we'll learn next.